All right, so this is objective 3-3. We're going to factor by difference of two squares, okay? We've already learned one way of factoring. What's that way? Greatest common factor. So today we're going to learn our second way to factor, which is a difference of two squares. So the first thing I want you to do is I want you to take a minute and I want you to multiply the quantity of x minus 2 times the quantity of x plus 2. Okay? Foil that together for me for just a second. So if we multiply this together, what will we do? X times x, which is x squared. Okay, then x times 2, which is 2x. Then negative 2 times x, which is negative 2x. Then negative 2 times 2, which is, and then what happens here in the middle? They cancel out, and you end up with x squared minus 4. Okay? What do you notice in the beginning about your two binomials? What do you notice about them? Like, let's find a pattern to make this easier on us. Do they look similar? They're the exact same thing, except one's a negative and one's a positive, right? Okay? This is what a difference of two squares is going to look like when I go in reverse, okay? First of all, this is called a difference of two squares. What does difference in math mean? Subtract. Very good. Subtraction, okay? Difference means subtraction. Sum means add. Quotient means divide. Product means multiply. So difference means subtract. So here's my question. When it's a difference of two squares, this should make sense to us. Are we subtracting two perfect squares? Is x squared perfect? What times what is x squared? Same number times same number. X times x. Very good. Okay, x times x. It's perfect square because it's the same thing times the same thing. Okay, is 4 perfect? What times what's 4? 2. So look at when we reverse it. First times first is the first piece. So what times what is x squared? X times x. Then last times last is going to be this last piece. So what times what is 4? 2 times 2. And what did we say it's going to be? 1 negative, 1 positive. Okay? And we just proved that when you FOIL it back together, that you will get x squared minus 4. Okay? But that's how we're going to work from x squared minus 4 to factoring it into two parts. It is a binomial times a binomial. So here's the question of the day. What's one of the factors? What are we multiplying together? X minus 2. We're multiplying a binomial times. So what's the other one? X plus 2. Okay? Like when I say give me two factors of 6, you tell me 2 and 3, right? Those are two things that multiply to be 6. These are two binomials that multiply to be x squared minus 4. Okay? Any questions on that? Okay. So, here we go. Let's look at example 1. So first of all, when we had a GCF, how many parentheses did we have if it was a GCF? Where did we put the GCF? Like if we were doing what we did yesterday. We put it on in front, and then we only had one set of parentheses, right? And we drew our blanks. Okay? If it's a difference of two squares, how many parentheses are we going to have? 2. It's going to break into two binomials today. Okay? And then we're going to say first times first is going to be this first part. Okay? So what times what is x squared? X times x. Then we're going to say last times last is going to be this last part. And you can, if you don't know what times what's 25, like you can take the square root of 25. Does everybody know how to take the square root in the calculator? You press the second button and then the x squared button. And take the square root of 25, which would be what? 5 times 5, and then what? One's negative, one's positive. I said that reverse. But it's okay. I did it on purpose because it doesn't matter. So if you look up here, this is saying that if it's a difference of two squares, you could do a minus b times a plus b. Like it could be a minus and then a positive. Or you could do a plus b and then a minus b. Doesn't matter which one's negative, which one's positive, because they're the same thing, as long as you have one of each. Okay? Now, like always, I want to be a professional cup stacker, right? So if you haven't been here in a couple of days, I told everybody the other day that in my next life, I want to be one of those people that build those towers. And, you know, they break them apart and make these cool towers, and then what do? Then they reverse it and go, and that's what, if you want to be the best, you can't just sit there and say, you know, here's a tower, and here's a tower, and here's a tower, and here's a tower. If I want to be the best cup stacker, I got to practice breaking it apart and then doing what? Putting it back together. So, if I want to be the best factor in the world, do you see? I have broken it into two pieces. What's one factor? X plus 5. What's the other factor? X minus 5. Okay, very good. If I want to be the best, though, and I want to make sure that I get 100 on the test, I'm going to put it back together. Okay? So, here we go. We're going to check it. So, x times x, x squared, x times negative 5, negative 5x, 5 times x, positive 5x, 5 times negative 5. Negative 25. When we're checking it, what's it going to help us do? Be able to do what better? Well, to check, but it's going to help practice our multiplication skills. Make sure we can FOIL, okay? So, x squared minus 25. And that does work, okay? That does check to be that, okay? All right. So I'm going to hit pause for a few minutes. I want you to try this one. But let me ask you, is this a difference of two squares? Are we subtracting two perfect squares? Is 16h squared perfect? Micah says yes. What is it? 4, be more specific. 4h times 4h. Ah, 4h. Sorry. Corny joke. Okay. 4h times 4h. Is 9 perfect? What times what? 3 times 3. So is this a difference of two perfect squares? Yes. That's why we call it that. Okay. So see what you can do with it. All right. So since it's a difference of two squares, we're going to draw how many parentheses? 2. Okay. Don't forget, when we go back and do what we did yesterday, we're going to put the GCF on the outside and only draw one set of parentheses. Okay? You got to keep track what you're doing. So here we go. First times first is going to be 4h times 4h. And then last times last is negative 3 and positive 3. Okay? Question of the day, what's one of the factors? 4h minus 3. What's the other factor? 4h plus 3. Okay? And I keep asking you that because on the test, like, how many of you, when you get into class, like, you understand what you're doing, and then you get to the test, and because it's worded differently, it confuses you? Yep. Agreed? So that's why I'm trying to prepare you, because on the test, it might say, factor this, and it might want the whole answer. It might want both factors. But then it might say, which is a factor? Like if I say, give me a factor of 6, give me a factor. 3, meaning, or 2, or 6, or 1. But it doesn't want what? It doesn't want the whole thing. It only wants one piece of it. That's why I keep asking you, give me a factor, which would be 4h minus 3, or give me a factor 4h plus 3. Those are the two binomials that are multiplying to be 16h squared minus 9. All right, let's check. So 4h times 4h, 16h squared. 4h times 3, 12h. Negative 3 times 4h, negative 12h. Negative 3 times 3, negative 9. And that does cancel, leaving you with 16h squared minus 9. Okay? All right, let's go down to number 3. What's different about it? Bigger numbers and double variables. Is it a big deal? No. Is it a difference of two perfect squares? Is 81a squared perfect? What would it be? 9a and 9a. Is 49b squared perfect? What would it be? 7b and 7b. So it's no big deal. Okay? Some people think factoring is really difficult. It's not. All right, so this will be 9a times 9a. First times first is going to give you your first part. And then last times last is going to give you your last part, which would be minus 7b and plus 7b. And then what happens to the outer and the inner? Why is there no outer and inner? Because they're going to cancel. Okay, that's why. So let's check it. 9a times 9a. 81a squared. 9a times 7b. Positive 63ab. Remember, you just smush them together. Okay, and this check step's going to help y'all do this. Like, how many with the double variable, you're like, like, the more you check, the better you're going to see how this puzzle works, and the quicker you're going to be able to do it. Okay? So negative 7b times 9a is negative 63ab, alphabetically. Then negative 7b times 7b is negative 49b squared. And the middles will cancel, leaving you with 81a squared minus 49b squared. Okay? Okay, try that one. Actually, I'm going to let you try both of these. Try 4 and 5. On your own, check it, make sure you got it. All right. So first of all, here's my question. Like, I'm getting ready to teach you 5 different ways to factor. The question on the test is going to be, how do I know which way to factor? Okay? So my question to you is, how do you know this is not GCF? Like, how do you know we don't do what we did yesterday? How do you know, like, does 121 and 4b squared have a GCF? Is there a number that can go into both? What is it?
Oh, come into both.
Yeah, into both. Is there a number that can go into 4 and 121? No, nothing other than what? 1, but if I divide both by 1, it's still going to be this, right? So, and can I take a b from both? Do you see what I'm saying? Like, if it has a GCF, then we need to take out a GCF, okay? But it doesn't have one. So A, you can cross off the list if we know GCF, and then we know difference of squares. That's how we know to factor right now, correct? So this does not have a GCF. So then we ask ourselves the question, is this a difference of two perfect squares? Are we subtracting two perfect squares? And yes, we are. So that's how you know how to do this. Okay, so this is going to be what times what? 11 times 11, and then plus 2b and minus 2b. Any questions on that? And then when you check it, how many were able to get that? Everybody okay? Good? All right, then we check it. 11 times 11, 121. What's 11 times negative 2b? Negative 22b. And then 2b times 11 is positive 22b. And then 2b times negative 2b is negative 4b squared. Those cancel, and you get your original. Okay? If we go down to the bottom, we're going to break it into 2. So what times what? 8g and 8g, and then
9h
plus 9h and
minus 9h.
minus 9h. Okay, what's one of the factors?
8g plus 9h.
8g plus 9h. What's the other factor? 8g minus 9h. And then you're going to check it, 64g squared. This would be negative what? 72gh. This would be positive 72gh. And this would be negative 81h squared. Those cancel, and you get 64g squared minus 81h squared. Okay? All right. So are we good with difference of two squares? There's one other thing that I want to ask you about. Yeah, this is good. All right. These two are going to hit it. So, what do you think? Okay, so we got our list, right? We've got GCF, and we got difference of two squares. Always look for this guy first, okay? Because if you don't get in the habit of looking for a GCF first, then you'll miss it, okay? So here's my question. Is there a number that can go into both? What is it?
3.
Be more specific.
3g.
3G. This has 3 G's, this has 1 G. I can take a G from both, okay? So, do I make 2 parentheses? Where do we put the GCF? In front. How many blanks do I draw? 2 blanks. So what would I be left with? 9g to the second minus 1. Okay, now here's the question. Are we finished? Remember I talked about that doctor the other day and how doctors have to go in and they have to double, after they do some sort of surgery, they have to go in and what? Recheck and make sure they got all the infection out, right? They got to make sure that they did what they were supposed to do. Go back and look on the inside. I want you, for a second, go back and look right here and tell me, are we finished? What is this? Is there anything you can do with that? Does anybody recognize anything with that? 9g squared is perfect, right? What times what is 9g squared? 3g and 3g. And? Is 1 perfect? What times what's 1? 1 times 1. And is this a difference of two squares? So could I take him and break him apart and make 2 more? You with me? 3g and 3g and plus 1 and minus 1. Okay, am I completely done?
Yes. And then you have to check it.
So if I just check this and multiply this together, I get 9g squared minus 3g plus 3g minus 1. Does that give me the original question?
No, then you have to distribute your 3G.
So is this just the answer? Who else is part of the answer? 3G. I'll give you my philosophy on 3G. Okay, 3G is our GCF. Okay, anybody have little siblings, little cousins that you ever have to take care of? Do your parents ever say, like if you're in the store, do they say, watch them for a second? So what do you generally, typical little brothers or sisters or siblings or cousins are being annoying, what do you do? Like, well, here, we're getting to that. So we're like, just sit there, be quiet, right? Go over there in the corner and play with your iPod or, do whatever you want to do. But at the end of the day, when mama, grandpa, daddy, whoever's ready to go, what do you do with your little sibling? You better bring them along because they are important, whether we think it or not. They are important. My son Chance, yesterday, he looked at me and he said, Mama, I cannot stand Reed. Like, I know they get on your nerves sometimes, but at the end of the day, they are part of the family. They are important. So I always think of the GCF like your little brother or sister. So right now, we're going to just say, go on. We're not going to pay attention to you while we do this part. But at the end of the day, they better come down and they better be included in your answer. So here's my question. If this were a test and it said, choose all the factors, what's one factor? 3G is a factor. They are important. What's another factor? 3G plus 1. What's another factor? 3G minus 1. And you got to have all three factors. Okay, if it's test day and you only pick 3G plus 1 and 3G minus 1 and you don't pick the GCF, it'd be wrong if it was a TEI item. Okay, so you got to have all of them. So let's talk about how we check this. Any questions on this whole thing is your answer? This is your answer right here. Okay, and we did both GCF and difference of two squares. So here's my question. How do you multiply three things together at once? So what did we do first? We multiplied two of them. You with me? Get an answer. So there's my answer, 9G squared minus 1. And then you take that answer and multiply it with the third piece, which would be 3G. And so we're going to distribute that and make 27G to the third minus 3G. And that will give you this piece. Did you follow me on that? Two together first. Get an answer. Then take that answer and multiply it by the third part. Okay, got it? Nobody finds that cool? Nobody wants to try that? Sorry. Okay. My Algebra 2 students use that a lot. Okay, and that's a big skill in Algebra 2 because you're going to end up multiplying three things together a lot, all the time. And everybody messes it up, and so we have to talk about it all the time. So when I look at them and I say, how do you multiply three things together? They look at me and go, and so then they do it correctly. Okay? All right, so let's talk about this. Okay? I don't want to make this a negative. I'm just going to make it a positive because I want to point out something. Okay, so we're just going to make this 4y cubed plus 9y. Okay? Let me finish. Okay, I'm almost done. This last one. Okay? You too. Yeah. All right, so is this a difference of two squares? Yeah. 4 and 9 are perfect. Yeah. But what's difference in math mean?
Subtraction, no.
Subtracting two perfect squares.
It's the sum of two.
Almost. Is y cubed and y perfect? Okay, so these are not perfect squares. If one little piece of it, like just because you see a 4 or a 9 does not automatically mean perfect squares. Do you understand that? Okay. A, number one, it's got to be difference. It's got to be subtracting. Number two, you got to look at your variables. Your variables are not perfect. So I can't do difference of 2 squares. So what else could I do?
GCF.
What GCF?
One Y.
You could take a y out. Okay. So let's take a y out. What will I have left? 2 blanks.
4Y squared
4y squared
plus
plus 9.
close parentheses.
So here's my question. Can this guy go further? Remember, we got to be like that doctor. We got to go back in and we got to look on the inside of the parentheses and make sure, did I get everything? So can that factor further? Okay, so I want you to do it. Okay, do it. Do it and check it for me and see if it works. Okay? Take a minute and record this. So, let's just check this. What signs do you think you need? You would think a positive and a positive, correct? Because a positive times a positive is a
I did positive times
positive.
negative.
Okay, so we'll do that in a minute. Okay, so that's going to give me what? 4y squared. This is going to give me 6y. This is going to give me positive 6y, and that's going to give me, what's the problem?
You have to use the division. Different.
So the problem is that the middles don't cancel, and then I end up with that, and that is not that. Okay? So then everybody says, okay, well, let's go back and do, make one of them negative. Okay? So I multiply it and I get 4y squared, negative 6y. Okay, they'll cancel. Then negative 9. And they will cancel, but what's the problem? It's a negative 9, and it should be a positive 9.
Then just change the sign. Just put a line through it.
So here's what I'm here to tell you. How are we factoring with squares? It's got to be what? It's got to be a difference. Subtracting, that is the only way you can get the outer and the inner to cancel and get a negative 9 at the end. So if this is a sum of 2 squares, it can't factor. Like it looks like, don't just look at it and be like, yeah, that can factor because it looks like it can factor. It's a sum of 2 squares. A sum of 2 squares cannot factor. So in this case, the only thing you could do is GCF. Okay? So add this into your notes. Last thing I want you to write. Super important. You might want to draw fire around it, draw a big box around it, do something. Okay? You cannot underline, 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 factor a sum. And if you don't know what the word sum means, you might want to put adding 2 squares. If there is a plus between them, you cannot do it. It is just absolutely not possible. That puzzle will not break apart. Because it won't ever, you can't ever get the middles to cancel and get the end to be a positive. It just won't work. There's no way you could do it. Okay? So like on the test, if you have this, x squared plus 9, and it says factor that, what would you say? One of the answers is going to be x plus 3 and x plus 3. And if you're not paying attention, and if you don't check it, you won't realize that that doesn't work. The middles won't cancel. So you just say it is prime or not factorable. Okay, you just can't do it. Okay, does everybody understand that? You cannot do a sum of 2 squares. It has got to have a subtraction in order for the puzzle to work. All right, so